Good morning, this is your Stat Sensei, Mr. Spensei, and this is a warm-up on uh, paired t-test, and we're going to be doing drugs for cheap. A growing number of employers are trying to hold down the costs that they pay for medical insurance for their employees. As a part of this effort, many medical insurance companies are now requiring clients to use generic brand medicines when filling prescriptions. A consumer group wanted to compare the active ingredient in a name brand drug and its generic counterpart. They randomly selected, this says 20, this should have been 10. So I'm changing that to 10 pharmacies in a large city, filled prescriptions for both the name brand and the generic drug, and tested a pill from each prescription to measure the active ingredient. Results are shown in the table. So if I look at this, I see that I have 10 generic and 10 name brand because we went and got 10 prescriptions filled at the 10 different pharmacies in generic and 10 prescriptions filled in with a name brand. Had this been 20, which is what it showed, which was a typo on my part, had it been 20, this would have been a two sample t test and generic, and we would have gone, oh, 10 came randomly selected from generic and 10 randomly for the name brand. All right. So as we move on and we actually look at what we're supposed to be doing, in the warm up, it says at the 3% level of confidence, do the above results indicate the name brand has more active ingredients than the generic? So, with that said, to test that out, I'm going to need to input that data into stat edit, which I've already done. Stat edit, and there it is in column L1 and column L2. I will need to find the difference, this one minus this one. So that's going to be blue button 1 minus the blue button 2. And there it populated the differences. Let's go ahead and get to work on our formula. Our formula is T equals X bar D minus mu D over SD divided by square root of N. All right. If I go stat calc, 1 var stat, L3, blue button 3, I end up finding my X bar is a negative 3.3. Now, please note that's not the mean of the difference. The mean of the difference would be assuming that there was no difference because it's a paired t-test, so we assume that there's no difference. Our standard deviation of the sample is 4.7853. And our sample size was 10. So if I'm setting this up, I'm drawing my curve, little ant, and we're centered at 0. That's the expectation. But we have a mean of, or an X bar of negative 3.3. And they said, does the name brand have more active ingredients than the generic? So what I did just now was I went generic minus name brand, which is L1 minus the L2. And we are expecting that to be less. And that's going to be important because we can go ahead and do our null hypothesis. Our null hypothesis is HO mu D equals 0. That's going to be true for almost all paired tests. So we have mu D and 0, but we're looking for a less than inequality. When we plug in, we have T equals negative 3.3 minus 0 divided by 4.7853 divided by the square root of 10. And this is a one sample paired t test for means. All right, let's go ahead and run this test. Stat test, t-test. We have data, so make sure data is highlighted. 0 is our mean, or we expect it to be 0, and that's what we have for our null hypothesis. Blue button 3, make sure we have the less than highlighted, and we calculated, and I end up getting a t equal to negative 2.18 and a p-value of 0.02. So the probability that t, because this is a less than, this is a less than, is negative 2.1807 equals, we have 0.0285 as our probability. So our p-value is 0.0285. Sliding back up, it tells us our at the 3% level, so this is alpha 0.03. And 285 is less than 300. So with our p-value being less, we're going to reject the null. All right. Obviously, we needed to do conditions, etc. But for this, that's all we needed to do. Just wanted to make sure that we could get the calculation done correctly. Appreciate you watching and look forward to seeing you on the next one. Thank you.